The human brain, it's just incredible. It holds an entire lifetime of memories, lets you recall things in an instant, and it's learning new stuff every single day without just wiping the old stuff away. It is by far the most powerful and efficient learning machine we've ever seen. And honestly, we've been trying to figure out its secrets for centuries.
And really, that's the big question, right? How does this little 3-pound organ sitting inside our heads manage to pull off feats that our most advanced supercomputers still struggle with? And it's not just about how much it can store, it's about the very way that it learns.
So, let's put our brains head to head with AI, with artificial neural networks. And wow, the differences are pretty stark. ANNs, they need huge data sets and just consume enormous amounts of energy. But the real kicker is something called catastrophic forgetting. See, when an AI learns a new thing, it can completely overwrite and forget what it learned before. Our brains, though, we learn continuously, in real time, folding new knowledge in without destroying the old. So how on earth is that possible? Well, the answer might not come from computer science at all. It might actually be hiding in plain sight, in a fundamental pattern that's found all throughout the natural world. And that pattern, it's the fractal. Now, the basic idea is actually pretty simple, but it's also incredibly profound. A fractal is just a shape where every little part of it is basically a tiny miniature version of the entire thing. It's nature's way of creating infinite complexity out of a very simple set of rules.
What's so cool about these patterns is this idea of self-similarity and scale invariance. It basically means they look the same no matter how much you zoom in. And they're made by simple, repeating processes, and we see them literally everywhere in nature. This isn't just some mathematical curiosity, it's a core design principle for building really complex, efficient systems.
Okay, fractals are cool, but what on earth do they have to do with our memory, right? Well, to figure that out, researchers decided to look at the actual rules our brain cells are using to learn.
They zeroed in on the hippocampus, that little seahorse-shaped part deep inside your brain. It's absolutely crucial for forming our episodic memories, the memories of events, of things that unfold in space and time.
And inside the hippocampus, they found this really unique learning mechanism called the Spatiotemporal learning rule, or STLR. Now, this is totally different from how most AI learns. See, typical AI learns when you tell it, "Good job, that's right," or "Nope, that's wrong." But the STLR is different. It strengthens the connections between neurons based on the timing and patterns of signals as they arrive. It's learning from the relationships within the data itself.
So here's the game plan they came up with. First, they built a digital model of a specific part of the hippocampus. Then they programmed all of its connections to follow this STLR rule. After that, they fed it hundreds of slightly different patterns over time and just watched to see what kind of structure would form in the network's connections. If you're finding this whole dive into the brain's secret code as fascinating as I am, hey, take a quick second to like this and subscribe for more. It really helps us keep breaking down these incredible topics for you. All right, so the experiment is running. What did they find when they finally looked inside that digital brain? What does a memory actually look like when it's built using the brain's own rulebook?
And what they saw was, honestly, it's just remarkable. As the network started learning, a super clear structure began to pop up. After just the first input, the connections split into 3 groups. After the second input, each of those groups split into 3 smaller groups. We're literally watching a self-repeating hierarchical pattern just emerge out of nothing. And once the network had learned all 243 patterns, this is what they saw. In the researchers' own words, quote, "The resulting visualization reveals a clear and detailed fractal structure, closely resembling a Sierpiński gasket, which is a famous type of mathematical fractal." They didn't just find some random pattern. They found perfect, intricate geometry hiding right there in the connections. And get this, it wasn't just that it looked like a fractal. They did the math. They used a specific technique to measure its complexity and calculated its fractal dimension. The result? 1.415. That is hard quantitative proof. The memory being formed was, mathematically speaking, a true fractal. So what does all this mean? Well, it points to this incredibly powerful idea called fractal coding. It's basically the brain's secret compression algorithm, like its own internal zip file. It's a way to take all this complex, high-dimensional information and efficiently pack it into a simpler structure. And by organizing memories this way, new ones can find their own little branch on the tree without messing up the old ones, a potential solution to that whole catastrophic forgetting problem that plagues AI. What's so amazing about this discovery is that it's probably not just some weird one-off trick the brain does. It actually connects to a much bigger pattern that scientists have been noticing all over the place.
I mean, listen to this from neuroscientist G. Werner. He speculated that using fractals would be, quote, a most extraordinary design principle for operational economy and complex systems. This new research shows that's not just a clever idea anymore. It shows the brain is actually doing it to manage its resources with incredible efficiency.
And it might go even deeper than just the brain. Some theories on fractal evolution even suggest that this same kind of stable, repeating geometry isn't just for making memories. It could be a fundamental blueprint for how life itself develops, from the simplest little organisms all the way up to us. So when you put it all together, what does it tell us? It suggests that the secret code for efficient lifelong learning, it isn't something our brains just invented from scratch. No, it seems to be a universal design principle, a fundamental pattern for building stable, complex, and efficient systems that's woven right into the very fabric of life itself.